Welcome to Rise Studies. Today we are going to cover the lesson Arithmetic Progression. It is a simple topic. Let's see what is this arithmetic progression. It is a number of sequence in which the difference between the consecutive term is equal through the entire sequence. So this is what we simply named as arithmetic progression or arithmetic sequence. Let us consider the natural number. Those are 1, 2, 3, 4 up to n elements. Okay. So this is an example of arithmetic progression. Look here, the difference between the consecutive term is equal through the entire sequence. If you consider the second term, that is 2, and the first term, that is 1, the second term minus first term, that is 2 minus 1, you get the answer 1. If you consider the third element and the second element, the third element minus the second element, you also get the answer 1. If you check through the entire sequence, you can see the difference between the consecutive term is equal through the entire sequence. So this is one of the example. So let us consider another example. Okay, you know there are 24 hours in a day, isn't it? There are 48 hours in 2 days and there are 72 hours in 3 days. This is also an example of arithmetic progression because the difference between the consecutive term is equal, that is the second term minus the first term, that is 48 minus 24, you get the answer 24. And the third number, that is 72 minus 48, you also get the value 24. Look here, if you check through the entire sequence, you can see 24 is the common difference of the sequence. Let us consider the odd numbers. Those are 1, 3, 5, 7, 9. It can repeat up to infinite number. Okay? So this is also an example of arithmetic progression because if you consider the second element, that is 3, and the first element, that is 1, 3 minus 1, you get the answer 2. If you consider the third element, that is 5, 5 minus the second element, that is 3, 5 minus 3, you also get the value 2. Look here, through the entire sequence, the difference between the consecutive term is equal. So let me tell you another simple example. Imagine this is your birthday. Your grandfather gives you a big piece of cake and you cut that cake into 10 pieces. So I am writing that here, that is 10 by 10, which means there are totally 10 pieces of cake on your hand and you are going to share that with your friends. So at the first time when you met your first friend, you gives him one piece of cake and the remaining piece of cake on your hand is 9 by 10 because 1 by 10 portion you just given to your friend. Okay. Okay, when you met the other friend, you are going to give him another piece of cake, that is only remaining portion on your hand is 8 by 10. If you give the cake again and again, it will decrease, isn't it? So the difference between that term is also equal because if you consider the first number, that is 10 by 10, and the second number is 9 by 10, I told you the consecutive term, that is 9 by 10 minus 10 by 10, you get the answer minus 1 by 10. Okay. If you consider the third element, that is 8 by 10 minus, and the second term is 9 by 10. So 8 by 10 minus 9 by 10, you also get the value minus 1 by 10. So this is an example of arithmetic progression because the difference between the consecutive term is equal through the entire sequence. Okay. So all the examples you can see, I am naming the common difference as the letter D, okay, and the first number you can see there are so many sequence present here and through the entire sequence you can see the first term, I am representing the first term with the letter X. So X1 I am representing X1, which means the first term. So you have to keep that thing in your mind. That means the X1 which represent the first element of the sequence and D represent the common difference of the sequence and N means the position or the rank in which the sequence exists. Okay. So friends, let us see how to find the nth element of the sequence. Here I mentioned some series or the progression, isn't it? So if you consider the first element is x1, I am representing x1 is the first element and I am adding no common difference with the first term. So I can write x1 plus 0 times common difference to get the first term. If you consider the second term of a sequence, you can see I am adding 1 times common difference with it, that is x1 plus 1d or d you can write to get the second term of the sequence. So I am representing x1 plus 1d. If you consider the third element of the sequence, that to get the third element we are adding 2 times common difference with the first term to get the third element. Look here, if this process is repeating up to nth element, n elements, so how will you find the nth element of the sequence? You can see here the first element, that is x1, is present through the entire sequence. So in the nth element, you also has to represent this x1 to the nth element side. Okay, so look, the difference, the common difference side, to get the first series. So to get the first sequence, we are adding 0 times common difference. To get the second number, we are adding only 1 times common difference. To get the third number, we are adding only 2 times common difference. So if this process is repeating up to the nth element, how many times you have to add the common difference? You have to add n minus 1 times common difference to get the nth element of the sequence. So you can simply represent, that is x1 plus n minus 1 times d. This is the equation to find the nth element of the sequence. So you have to remember that it is the simple way to find the nth element.